All right, let's do section 9.3, page 461, number 13, which reads, show that the two functions grow at the same rate. And our functions are the natural log of x and the log base 10 of the square root of x. Now, before we can start to show that they grow at the same rate, we really need to get both of these functions in terms of the same type of logarithm, namely natural log. So I'd like you to recall from, I think it is chapter 2, that we can take any log base a of x and express it in terms of a natural log. And that's going to be the natural log of x over the natural log of the base, which is a. So now we can take our log base 10 of the square root of x and express it in terms of this other form. So just to follow what I've got going on up here, I'm going to take the natural log of the square root of x divided by the natural log of 10, which is just a number. And I'm going to simplify this a little bit more. I'm going to remember, first of all, that the square root of x is really x to the 1/2. And I'm further going to remember that when I have a log, I can take this exponent and bring it down in front. So I'm going to have 1/2 times the natural log of x over the natural log of 10. And then really, I'm just going to do a little algebra here, and I'm going to bring that 1/2 into the denominator so that I've got 2 natural log 10 in the denominator, and that is just a number. So now I can get back to my problem, which is to show that these two functions grow at the same rate. Well, I'm going to let one of them be f of x, and I'm going to let the other one be g of x. And I know that if I take the limit as x goes to infinity of f of x over g of x, that is going to be equal to a constant if those two functions grow at the same rate. So I just want to work out what this limit's going to be, and that should tell me if they grow at the same rate. So I'm going to have the limit as x goes to infinity. My f of x is the natural log of x. My g of x is this log base 10 of the square root of x, which I have shown to be the natural log of x over 2 times the natural log of 10. I can do some canceling here. I've got a natural log in both the top and the bottom, and that's going to give me the limit as x goes to infinity of 1 over 2 natural log 10. And as we've learned and said before, the denominator of a denominator is a numerator. So this is going to give me 2 natural log 10. I can get rid of my limit here because I'm only dealing with constants now. I've canceled out all of my x's. And my limit does in fact give me a constant, which tells me that these two functions grow at the same rate.